we're now recording. So let's get the slideshow set up. Before we get there, here's a few announcements. Some of these, I don't know if you important to you or not, but here's the first of these is from a company called First Call Quality Services. They're out of Indianapolis, Indiana, and they're going to be right next door to us here today in the One Stop Career Center. It's in the Millsap building. That's the building just outside the loop that you may drive around when you park in the back of the building. They'll be taking applications for, and they say a job fair, which seems sort of weird, but here are what they're looking for. Quality inspectors, starting at $11 an hour, not too bad. Team leaders, starting at $13.50 an hour, not too bad. Today is when they're here, Tuesday, March the 6th, at the One Stop Career Center from 9 this morning until 1 this afternoon. Okay, now this would be for y'all if you're interested, but also for anyone. If you know of anyone in your community, your family, anywhere that is looking and may have interest in this type of thing, let them know. Get them here before 1 o'clock. Now, in addition to decent pay, benefits are also available. Applicants must have a clear background check, a driver's license, high school diploma or GED, and automotive manufacturing experience is preferred but not required. Okay? And then I have the phone numbers for a couple of ladies who work over there if you want to call and find out. This is today before 1 o'clock. Starts at 9, goes till 1. So if you know of anyone, let them know. Also, if any of you are interested in the math team, it's a fun time, fun bunch of people. You really, in a really good, easygoing session, you learn math really, really well. Ms. Nyla Gerasi is our coach for the team. She's having practice sessions Fridays at noon and Mondays at 3 on the Birmingham West Campus, the Science Building, which is the C Hall, C100. Okay? So please get in touch with her, find out more information. She's really beginning the practices now for next year's competitions. Now, tutoring schedule, I think I've shared this with you before on Bessemer campus and Birmingham campus, various tutoring opportunities we have. And then the other question is, are any of you graduating this term? You are? Okay. You know about the graduation meetings. There was one last evening on the Birmingham campus. There's one at 1:30 today over here in Ethel Hall Auditorium. And then the last one will be at 1:30 tomorrow afternoon on the Birmingham West Campus in the ACAT building, first floor theater. Okay? And if you have any questions, Ms. Janine McCoy-Jones on the Birmingham campus or Ms. Lloyd Chisholm on this campus are giving us a contact. I have numbers if you need them. Anyone else come in since I called roll? I think I got everybody. Now let's hit a few more announcements that are not on the pieces of paper. Don't know if you're aware of it, but we just passed midterm. Yesterday was the last day of first mini-term. Today's the first day of second mini-term. So last night around midnight, I guess, was midterm. Okay, right on the nose. So starting today, my schedule changes. Okay, I haven't gotten it changed in the on Blackboard yet, but I'll try to do that. I'll change it on the syllabus, and I'll also change it on my locator card, if and when I can ever get time to sit down and do it. Okay. Right now, I'm trying to work on the syllabi for and setting up the classes that I'm picking up this term. Let me go over them briefly. Okay, today and Thursdays. Before today, I had office hours from 10:45 in the morning until 5:15 in the afternoon. Bye-bye. Okay, no. Okay, from today on, 10:45 in the morning until 1:15 in the afternoon. I pick up a second mini-term physical science class. I have 20-plus students in it. And it starts at 1:15. A lot of them are automotive students, so that's why it's a weird start time. They finish their block of classes at 1, So I give them a 15-minute break, probably to grab lunch and everything else to get over here. And we start at 1:15. Because it's a mini-term, the class goes 2.5 hours each time we meet. So that's 1:15 to 3:45 is the class, and then 2 hours of lab every time we meet. 3:45 to 5:45. So I'll be getting out of lab about 5:45, hopefully leaving campus by 6. So no real time for office hours in there after 1:15. So today and Thursdays, Tuesdays and Thursdays, 10:45 to 1:15. Okay, before this week, today, my Monday, Wednesday office hours were 7:45 in the morning to 9:30, still going to be that. Then 11:15 to 2, still going to be that. But yesterday and before, it was 3:15 to 5:15. That one's gone because I picked up a physics class on the Birmingham East Campus that starts at 4. So as soon as I can finish my 3:15 class here, get all my stuff together, and get over to Birmingham, I don't have much time for office hours at all there. I'll be there from 4 until 6, and then leave to go home about 6:15, something like that. Well, the first Y chromosome showed up this morning. Gavin's here. All right. Anyone else coming since I called roll? I don't see any. Okay. So, let's see what else. One other little thing that deals with midterm. Technically, they usually open up what they call midterm progress reports, that we're supposed to make a report on how people are doing at midterm. Okay? So far, you've had 2 potential scores. Your paper hasn't been due yet, but several of you have turned that in. Let me say a few of you have turned that in. 5 of you have turned that in out of my class of 20 some odd students. Melvin's here. So I have scores for those 5. And then the quiz you've had for several weeks now. I should have those in by now. I don't have everybody's, but I do have more than half the class. So those folks do have scores. If you haven't turned in a paper or the quiz, I have 0 score for you. So when they ask for the midterm progress reports, if I don't get something soon, I've got to turn in an alpha midterm. Not that it's going to hurt you anything, but I do need some sort of grade. Otherwise, you get reported as an alpha midterm. Again, there's no penalty in that. It's just you'll probably have people from the counseling service or somebody calling you, contacting you, trying to find out what's going wrong. Do you need tutoring? That kind of stuff. So try to get me your quizzes in today, tomorrow, and you definitely have to have them in by Thursday, because Thursday we're going to have your test on Chapter 1. You can't take the test until you've turned in the quiz. Or you can ask me politely to give you a 0 on the quiz. I won't want to, but if you ask politely, I have to do so. Okay? So please get me your quizzes sooner rather than later. Those who have turned in the quizzes, they're graded, and you can see them anytime. I just can't return them to you until I get all of them in, because otherwise the correct answers will be floating around out there, and it cheapens your score who did it, if anyone happened to see the answer. Okay. Any questions before we move on? All right. Sorry, that took way too long. We finished example 6. I was just trying to see if there's an example 7 here. My mark said we finished example 6. Okay, no, there is no example 7, so we'll do that now. Any questions on anything before we begin? Okay, example 7, the last example in section 1.9. Find the inverse function. Let me get my pen activated. Okay. Find the inverse function of f of x is equal to the square root of 2x minus 3. Okay? Find the inverse function of it. Is there anything when you look at that function that you have an urge to deal with? Anything about that may send off alarms or sirens or just little beeps and saying, check this out, folks? Anything? Second? Second? The square root sign. What do we know about square root signs? Okay, not quite, but everything that lives inside that square root sign has to be what? Yes, non-negative. So how do we express that mathematically? What's living beneath the square root sign? What's there? Read it. 2x minus 3, and what you just said was? Both sides of what? I need. What is true about anything that lives inside the square root? Can't be negative. How do we express that mathematically? Say again? Change what to positive? Okay. How do we express it can't be negative, has to be positive? How do we express that mathematically? In sort of a mathematical sentence. 2x minus 3 must be, if it can't be negative, it's got to be, say again? 2x plus 3, yeah. Okay. What about it? It can't be negative. It's got to be positive. How can we express that mathematically? Did someone say something? That's right. Yes, exactly. That means it can't be negative. It has to be greater than or equal to 0. Doesn't that say what you just said? It can't be negative. It's got to be greater than or equal to 0, right? Now we've got an inequality we can solve, and how do we do that? Okay, we're not going to do that yet. We're going to add 3 to both sides. Okay, and what does that give us? 2x greater than or equal to 3. Now what? Yeah, divide both sides by 2, and that gives you x is greater than or equal to 3/2, 1.5. All right, I must have been psychic, because I marked Taylor here by mistake, and here she is. Okay, so remove the questions there. She is here. Okay. So, what that means is x is always greater than 3/2. Okay. Now, the reason we did that, what are we supposed to do with this? Help me. What was the find the inverse, okay? First, we have to determine whether the inverse exists or not, right? So, we know that the domain of x has to be greater than or equal to 3/2. What's going to tell us whether this has an inverse or not? Say again? Well, yes, to see if it's a one-to-one function. What does it mean to be a one-to-one function? Say again? Okay, we've already done that for the domain. Say it again? Yes, it passes the horizontal line test. Okay, now the question is, can we do that without graphing? What you think? No? Okay, then let's graph it. Okay? So let's sit down to graph. And you know your x's are always greater than or equal to 1.5. So I don't need any negative x's in here. I don't even need all the positive x's. Okay? Now, what can you tell me about the y's? What is y? Oh, boy, I thought you... Huh? What is y?
What?
On the very beginning, I told you what y was. It's the one thing to remember in this course that helps you with functions more than anything else. It's f of x. Y is equal to f of x. Remember? Oh, it's been a long weekend, right? Okay, y is equal to f of x. Remember that, folks. That's what. Okay, now this f of x, what can you tell me about its values? You think they're all real numbers? Can this thing right here ever be, say, negative 15? No, because that is a positive, a principal square root. You're only doing the positive values of that. So this thing right here, the y, can't be negative. So I don't need any negative y. I don't need any negative x's or negative y. So I picked this to be. In fact, my x's are not going to start at 0. They're going to start at 1.5. There's where they begin. And when x is equal to 1.5, what's in here? 3/2 times 2. 3/2 times 2. Times 2? 3. Minus 3? 0. The square root of 0? 0. Okay, so that's where my y is starting. So there's our first point right here. Okay? Now, I really don't want to have to plug in too many things, but we can. The next one will be pretty easy. But here's how I do it, the square roots, because they're really awkward. Okay? So what I do, I wish upon a star, okay, that this thing right here was a 1. Because I know what the square root of 1 is. So I'm going to sit down and say 2x minus 3 is equal to 1. And then I would 2x minus 3 is equal to 1. Same thing we did here. Add 3 to both sides. You get 2x is equal to 1 plus 3 is 4. Divide by 2. Did I just mess that up somehow? 2x minus 3 is...
No, 3 times 2, right?
Second?
3 times 2, right? 3 times 2.
Oh, yeah, wait, yeah.
It all equals 3.
Okay. Yeah, you're going to get a fraction. You are. Okay, that's right. I think you are. So if that's equal to... Okay. Yeah, you're going to get a fractional form. And I just don't like those fractions too much. But the point is, this thing is increasing, right?
Right.
As you increase the x. So the square root is increasing from 0. So this is going to be, how does your square root function look? Like half of a sleeping parabola, right? It goes up like this and does something like that. Always increasing. Okay, I didn't.
You went from negative to positive.
No, we didn't go negative to positive. We started positive and stayed positive.
Okay, so you start at 1/2.
At 3/2.
3/2.
Yeah, okay? Start there and go. So that's passes the horizontal line test everywhere, right? So therefore it is a one-to-one function. Whew. That's step 1, folks. Okay? Got it? So, we know it's a one-to-one function. Let me erase all this. Okay? We don't even need that. But remember, I'm going to leave that. X starts at 3/2. Greater than or equal to 3/2. All right, someone was telling me what the next step was. It's a question I've already asked this morning. It took you forever to answer. Change the f of x to y. Exactly. We got it much quicker that time. Y is equal to the square root of 2x minus 3. Now let's, yes?
Repeat the step again. You can change the f of x to y.
Cool.
Change the f of x to y.
Yes, exactly. Remember, the question is, what is f of x usually? It's equal to y. So let's just make it y, okay? Now, what's the next step?
We repeat the same step.
Second?
Repeat the same step.
You mean change it back to f of x again? That would take forever.
No, I was going inverse.
Say again? Exchange the x and y. So this becomes x is equal to the square root of 2y minus 3. Okay? Now, what's the next step? Solve for y. Now, what's the first thing you got to do to solve that thing for y? Don't take the square root. Yeah, you got to make the square root sign go away. How do you undo a square root? Square it! All right. So we will square this, making it x squared, and square that, losing the square root sign. Right? So now we have, I'm going to swap sides. Is that okay? I was on the affirmative, now I'm on the negative. Okay? No, I'm sorry. 2y minus 3, once you lose the square root sign, is equal to x squared. Okay? Next step. Yes?
Yeah, we all take the word a squared equal to 2y minus 3.
Say that again.
Would you recommend us putting x squared equals to 2y minus 3?
That's fine too. I just like, since I'm solving for y, I sort of like having y over here. That's just my preference. You can do it with it on the other side. Perfectly fine. Okay? Next, we're solving for y still, remember? Yeah. Taylor is here. Make sure I have already marked you here. There you are. Anyone else coming since I called roll? Okay, what's next? Did I hear an add 3 to both sides? All right, that's what we got then. Add 3 to both sides. What does that give us? 2y is equal to x squared plus 3. Next, divide everything on both sides of the equation by 2. Okay? So now we have y is equal to x squared plus 3 divided by 2. Okay? One more little step here. Well, actually there's 2. Next one's a big one, but this is a little one. What do we do next? No. We got what we wanted. Y is equal to x squared plus 2 plus 3 over 2. Sorry, I can't write. Okay? Say that again? Yes! Now we found what we think is the inverse function of f, which we name f inverse. Okay, good deal. Now, what's that last step, the one we've been looking forward to since the very beginning? Last step is to, here's what we think may be the inverse function. What do we do with it? Okay? I think I know what you're meaning now. I think you quite said it right. We determine the, goodness gracious, going blank on the name. Compose f with f inverse. So I think I will get rid of my 3x. This is just in the way here. All right. So we compose the two functions together. And it doesn't matter which order, you got them do both. We do f of f inverse of x and see what that becomes. Okay? What do we plug in first? Say again? What do we plug in first? No. we do the internal one first, the innermost one first. Once you mark Kadarius here. Okay? How to do that first, okay? We're on example 7, page 89, last example in 1.9, and it's taking forever. No, okay. You plug in the innermost one. So leave the f alone, that's the square root function. Plug in what f inverse is. X squared plus 3 over 2. Now what? Now what you were saying? Okay, now we plug that in here. Everywhere we see an X here, we're going to plug that in instead of the X. So that's going to be, I'll put it over here, the square root of, because that's what your F function does, is take the square root of what? 2. Wait. Instead of X, we put in what's in the parentheses, which is X squared plus 3 over 2, and then we subtract 3 from that, right? Agreed? You see why? You don't. Okay? Was that not a shaking of the head, no? Okay. You're doing f of f inverse. This is f inverse. Plug that in instead of it. Now, what the f function says to do here is whatever's in the parentheses, you take the square root of 2 times this minus 3. So the f function says take the square root of 2 times whatever is inside the parentheses, which is this, and then subtract 3 from it. That's what the F function does. That's what that machine does. Takes the square root of 2 times whatever you put in and subtracts 3 from it. Okay? All under the radical. Okay, so what do you do next? Okay, yeah. The 2's. 2 over 2 is 1. So that gives you the square root of x squared plus 3 minus 3. And now what? The 3's add to 0. And that gives you the square root of x squared. And what's that? X. Ding, 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 ding. That's what we want. We want that f of f inverse to be x. Okay? But we got one more step, or at least half step. And what's that? To reverse them. Okay? Now, I need a little more room, so I'm going to erase a little bit more here and see if we can get it to work. So what's that next and our last step, we hope? Rather than do f of f inverse, we do f of inverse of f of x. And what is that going to be? Get out of there. What do we plug in where? Okay. F inverse of, what were you saying? Yeah, the square root of 2x minus 3. Okay. Now, you plug in the f of x, there it is, into there. Now, that tells us to do f inverse operating on that. What does f inverse do? Here's f inverse. What does it tell us to do? Whatever's inside the parentheses, the first thing you do to it is square it. And what's inside the parentheses here? That radical, right? So what we do is you do the square root of 2x minus 3, that's what's inside the radical, and you square it. and then you add 3 to that, and then divide the whole thing by 2, right? That's what F. Is it Jasmine? No. I'm sorry? I can't hear. Oh, you were already here. Sorry. Okay. Okay. Do you see where that came from? You're doing F inverse of F. F was this, and F inverse is this. And it takes whatever's inside the parentheses, squares it, adds 3 to it, and divides the whole thing by 2. So what do we do first there? And what does that give you? 2x minus 3 plus 3 divided by 2. And what do you notice you can do first? 3 minus 3 is 0, and 2 over 2 is 1, and that gives you x. Ding, 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 ding. We have another winner. Okay? So we have shown that F of F inverse is x, F inverse of F is x, therefore these are inverse functions of each other. So what they ask us to do, find the inverse of F, sure enough, there it is, x squared plus 3 over 2. Make sense? All right, Chris decided to show up this morning. Good. All right, was there a question? Yes. I mean, what?
Thursday.
Oh. How many
Probably
do you
on the
need?
10th Thursday.
No, I ain't talking about deep. I'm talking about how many answers we're gonna have. Like, we got like 3 answers to do.
Okay. Now, to find an inverse, there's several steps. Here is where you found what you thought was the inverse. Okay? And then it's always a good idea to verify that. You don't have to. You can put that down as your answer. But if it's wrong, you have to finish the problem. You lose it. But if you went back and verified it, you get everything right. Now, if you got it right down here and didn't verify it, that's what I asked for. What is the inverse of the function? But the rest of it is verifying. Now, I want to say, I think this is right, there is, I think, a question on the thing of show that these two functions are inverses of each other. That's a show me. So you have to do both of those steps. You have to do F of F inverse, and you have to do F inverse of F. And if you're going to show me they're the same, what did the answer better come up being? X on both ways. So for that one, you got to, that's not just find the answer, it's show me that these are inverses of each other. So you do have to do that part of it for that problem. Okay? You have to do F of F inverse and F inverse of, I think they're called F and G or whatever, you know. Show that they're inverses of each other, you have to do both steps there. Show it. When it says find the inverse, there you found it. The rest of it is verifying it. Okay? Is that what you're asking? Okay, and what he's asking is how many problems on the test? You're pretty interested in that. Okay, the quiz, I think, was 10 questions, multiple parts, right? The test is going to be approximately 20 questions, multiple parts, okay? I usually try to give as much partial credit as I can, so if there's several blanks there, you know, fill them all, okay, because you get credit for everything. So don't leave anything blank in general, okay? Try to work it out somehow, okay? I can give you partial credit for doing right procedures, even if you get a wrong answer. If it's a blank, can't give you any partial credit for a blank, okay? So always try to do something. All right, now, the one last thing that the book does, besides mark CJ present, is they graph it, okay? And now I regret that I had to erase what I had before, okay? But I'm going to approximately do that again. Remember, we had 1, 2, 3, 4, 5, 6, 7. We didn't do all those. We started at 1.5 here and basically went something like that. Okay? Now, this F inverse, what color do you want to plot that as? Okay, now red I'm going to use for something else. I'll go on and use the red. Red is our identity function. I need that. So pick another color for F inverse. Orange, okay. All right. Now, how do I plot F inverse of x being x squared plus 3 over 2? Now, here's another timeout, okay? And remember what we did at the very beginning. Very beginning, we said for the F function, x has to be greater than or equal to 3/2. But we also said that the y for here, the F here, had to be what? Positive, greater than 0, okay? Now, the second step here, we flip the x's and the y's, right? The first step was this, the second step, we exchange, okay? Well, if the y up here had to be greater than 0, that means the x of the inverse function has to be greater than 0. So we're going to start the inverse function, this one, on the y-axis. And then the y for the inverse was the x for the original function. It's going to start at 3/2. So if we do that, I'm sort of doing it probably too fast. It's going to start at 3/2, 0, 3/2. See, this one was 3/2, 0. This is 0, 3/2. And then it's going to be half a parabola. And look at that. They reflect across the across the identity function. If I drew well, it would be even better, but I don't draw that well. Okay? You don't have to do that, okay? But it does sort of give you a visual. Yep, we seem to got that one right. You can plug in the values and see what you get. X equals 0 would be 3/2, right? X equals 1 would be 4/2, which would be 2, okay? X equals 2 would be 4 plus 3 is 7 over 2. That's 3.5. So you can plot those and you'll follow that parabola. Okay? Was there a question? Okay. Huh? Yeah, it certainly was. There is a checkpoint there, folks. Hey, you can always do your checkpoints. Audio video solution or at larsonprecalculus.com. All right, that finishes 1.9, okay? So let's move on to the vocabulary on page 90. If f of g of x and g of f of x are both equal to x, then the function g is the blank function of the function f. F of g of x and g of f of x are both equal to x, then the function g is the blank function of the function f. The inverse function, perfect, okay? Number 2, the inverse function of f is denoted by, what symbology do we use for that? How do we express it? How do we express the inverse function of f? What's the symbology we use? It's on the board. That's why I brought it back up. What is the inverse function of f? Can you find it on the board?
Y equals x squared plus 3 over 2.
Say that again now.
Y equals x squared plus 3 over 2.
Okay, that's close. Here's the symbology for it. You got that part right. That's for this specific function. For any function f, it's f to the minus 1. That doesn't mean 1 over. That means inverse of the function. F inverse of x. F to the minus 1 of x. Number 3. The domain of f is the blank of f inverse. We just said that with the graphic. The domain of f is the blank of f inverse.
2x minus 3. 2x.
The domain of f, don't do this specific problem, any problem. The domain of f is the blank of f inverse. The what?
Greater than or equal to 0.
Okay. That was this problem. Okay. The domain of f is the blank, looking for a word of f inverse. What word do you associate with domain? Range. The domain of f is the range of f inverse, comma, and the blank of f inverse is the range of f. Help me, folks. Domain, of course, okay? Number 4. The graphs of f and f inverse are reflections of each other in the line. What line? What line? It's on the board. We just did it. What line? What line do you see on the board? Again? It was like the second step of your process here. Okay, that is a curve. That's not a line. Say again? I don't, okay, the only horizontal line I see sort of is the x-axis. I don't think that's what it's reflected across. I don't see anything reflected across the horizontal x-axis. What do you see the reflection across?
The x-axis.
The what?
The x-axis.
This is the x-axis. It's not reflected across there. It's what?
It's the y.
The y-axis is here. Is it reflected across there? No. So those are 2 of the 3 lines that are on the board.
The red one.
The red line! Okay, and what is the equation of that line? Say again? Y is equal to x, of course. Remember, that's what we did at this step. We exchanged the x and y. We say y is equal to x, x equal y. Okay? That's what it's reflected across. We also call that the identity function. Okay? Dennis this morning. Okay. Number 5. The function f is blank when each value of the dependent variable corresponds to exactly one value of the independent function. The function f is blank when each value of the dependent value, that's y, is equal to exactly one value for the independent variable, that would be the x. What would that be? We said it at the very beginning. One to one! Oh my goodness gracious, how soon we forget. Okay. Number 6. A graphical test for the existence of an inverse function of f is the blank line test. Horizontal line test, excellent. My goodness gracious. Pulling teeth here, okay. Homework exercises here. Do any of the odds 7 through 13. All those odds are in countchat.com. They're also in the back of the book. The answers are, but the worked out solutions are at countchat.com. Number 9 is on calcview.com. They give you a little more interaction there. Then do either 15 or 17 or both. Both of them are at CalcChat. 15 is at CalcView. Do number 19. It's only at CalcChat, but it's pretty easy to do. Then do any of the odds 21 to 31. They're all at CalcChat. 23 is at CalcView. Then do 33 and 35. They're only at CalcChat. They're not at CalcView. Then do either 37 or 39 or both. They're both at CalcChat, not at CalcView. Then do either 41 or 43. 41's at they're both at CalcChat, 41's at CalcView. Then do any of the odds 45 to 53, and they're all at CalcChat, only 45's at CalcView. Then do any of the odds 55 to 69, they're all at CalcChat, 61's at CalcView. Then do any of the odds 71 to 77, they're all at CalcChat, none of them are at CalcView. Then do any of the odds 79 to 83, they're all at CalcChat, none at CalcView. Then do either 85 or 87, they're both at CalcChat, not at CalcView. Then do 89, and there's a true-false number 91. Hopefully all these are at CalcChat. Do 93. It's a CalcChat too, I think. You can, if you choose to do a proof number 95, I don't know if it's a CalcChat, it should be, and then think about it either 97 or 99. And then 101 is just a one-to-one function representation, so you might want to take a look at that. All right, we're going to skip 110. We just don't have time for it, so we'll skip 110. If you need that for any of your future studies, I would say go over on your own. If you have any questions, I'll be glad to answer them. Okay? So 1.10 is not done. Chapter summary is on page 104 and 105. Okay? We didn't do 1.1 or 1.2 or 1.3. Now, some of that may be useful to you, but we didn't do those. So you can start at 1.4, 1.5, 1.5 is on top of page 105 as well, 1.6, 1.7, 1.8, and 1.9. Basically, a lot of your formulas and equations are there. Now, time out. Remember I said at the beginning of the term, you can bring with you to any test, to every test, including the final, a formula and equation sheet. So anything you want to write down on a piece of paper, you can do, okay, and bring with you to the test. Some of that you'll find maybe in the chapter summary might be useful to put down. This chapter summary has a little bit less than some of them, but it has. Now, there's also review exercises at the end. Okay, I wouldn't worry with 1.1, 1.2, and 1.3. So starting on page 107, if you want more exercises, all the odd numbers are calcchat.com. So 43 or 45, 47, 49, 51, 53. Those would all be good review exercises. Number in 1.5, you got 55, 57, 59, 61, 63, and 65. All good review exercises for 1.1 and 1.5. 1.6, 67, 69, any of the odds 71 to 79, that is 1.7. Okay? Actually, I messed that up. 1.6 has only 67 and 69. 1.7 are any of the odds 71 to 79. 1.8, 81, 83, and 85. 1.9, 87, 89, 91, and 93. You don't have to worry with 1.1. Okay? Then we have the chapter test. Okay? Now, the chapter test, I think all the answers are in the back of the book, but only the odd numbers are at CalcChat. So you can do, and by the way, the first of these are from 1.1, 2, and 3 we didn't do. So where we pick up in here, pretty exciting stuff is number 10. So starting with number 10, you can do any of those from 10 till 23. Okay? 24 through 26 are the 1.10. All right. So those are good things to study for the test. And the test will be on Thursday on 1.4 through 1.9. Okay. Okay. Wait a minute. How much time do we have? Oh, we have 15 minutes. That's good. All right. So we're going to close that. Backwards here. Backwards there. And we're going to start in chapter 2. And you'll find out that chapter 2 is just a continuation in many respects of chapter 1. The only difference is chapter 1 was really general. We talked about all kinds of functions. Okay? Chapter 2 is dealing with only two types. Polynomial functions, and then the last section will be rational functions. So the first 5 sections are only talking about polynomial functions. So we'll do 2.1 to 2.5, all deal with polynomial functions. And we're really going to skip a little bit of 2.4. I'll just go over with it quickly. I'm not going to test you on it. Okay? But then 2.6, rational functions we'll skip 2.7. Okay? So let's get started from the current slide. Okay. Polynomial and rational functions. Okay? 2.1 deals with quadratic functions and models. Okay, what do we call quadratic functions in the last chapter, in chapter 1? I did use the term, the book didn't use them as much. We called them the squaring functions. Those functions that the maximum exponent is 2. And in chapter 1, we did all sorts of exponents. We did exponents of fractions, exponents with 3, 4, 5, it's just all sorts of. 2.1, we're only dealing with exponents of 2. Okay? So we'll analyze the graphs of quadratic functions. We've already done much of that. We'll just do a little more detail. We'll write quadratic functions in what they call standard form. You might say, oh, we've been doing that. Well, from earlier courses, we had what we called the standard form of a quadratic equation. That was ax squared plus bx plus c is equal to 0. That was standard form for a quadratic equation. That's not what we use for standard form for a quadratic function. We'll talk about that, okay? And we'll use the results to sketch graphs of functions. Now, I don't know if you remember back when you did linear equations. This was in Math 100. If you did 098, we're doing it in that. Right now, I'm teaching a course in that. They called the standard linear equation ax plus by is equal to c. It's a nice looking form, but it doesn't tell you anything. The better form is y is equal to mx plus b. The m tells you the slope, the b tells you the y-intercept. You can graph the function just with it in that form. It's so easy. Standard form tells you nothing. Well, same thing here. Standard form for a quadratic equation, ax squared plus bx plus c is equal to 0. That tells you almost nothing about the graph of the function. One little piece of information, 2 maybe, you can get out of it, not very good. The standard form for a quadratic function, that's like slope-intercept. Everything in there, every parameter in there tells you something useful. Okay, so that's what we'll do there. And we'll find minimum and maximum values of quadratic functions in some real-life applications. So let's start with the graph of a quadratic function. You should already know this, but let's go back and review. In this section, you'll study the graphs of polynomial functions. you were introduced to the following basic. What do we call f of x equal ax plus b? It has a special kind of name. What do we call that? A linear function. And what are the important aspects of it? B is the y-intercept. A is the what's A? We used to call it M. Slope. The slope of that line. Okay? Now, that's also a special function. What do we call fx equals c? Constant function. Okay? And how about this one? F of x equals x squared. The squaring function. That one also is a quadratic function. But all three of these are polynomial functions. This is what we call a 0-degree polynomial because it doesn't have any exponents in it. X to the 0th power is 1. So it doesn't have, this is the first degree polynomial function. That's the second degree. You look at your exponents of the variable to give you the degree. So all these are polynomial functions. To be a polynomial, all those exponents, every exponent has to be a positive whole number. No fractions, no negatives. If they were negative, not a polynomial. Fractions, not a polynomial. So that we did before, square root of x, 2x, or x squared, or whatever it was, plus 3 or minus 3, that was not a polynomial function. That was a radical function. Okay? So here's the definition of a polynomial function. N has to be a non-negative, no negative exponents, integers, no fractions, no decimals, positive, non-negative integer. Okay? And then the a sub n's are your coefficients. These n's don't do anything but be markers for these coefficients. A sub n means it's the coefficient that goes with the power n. A sub n minus 1 means it's the coefficient that goes with the power n minus 1. A sub 2 means it's the coefficient that goes with x squared. A1 means the coefficient goes with x to the first power. A0 means it goes with x to the 0th power, which is 1, which you don't see an x there. Those are real numbers, okay? They don't have to be integers. They don't have to be positive. They can be fractions, decimal, rational, or irrational numbers. Doesn't matter, okay? The only thing that's required is this a sub n cannot equal 0. Now that may seem like a strange thing to require, but here's why. Because of the last line there. This function then, f of x equals some coefficient, any real number, coefficient, a sub n times x to the nth power. This n is important. That's the exponent. This n is a marker. That just means it's the coefficient that goes to that n. Plus a sub n minus 1, that's just a marker for that coefficient, times x to the n minus 1, that's the number that is important in the function. You step on down till you get a sub 2 x squared plus a sub 1 x plus a sub 0. That's a polynomial function of degree n, or with degree n. That's why a sub n can't be 0. If a sub n was 0, then this would be a polynomial function of degree n minus 1. So to be degree n, a sub n can't be 0. That's the only reason. Okay? Now, are we doing? Oh yeah, we got 5 more minutes. Polynomial functions are classified by their degree. I already said that on the last one. For instance, the constant function, f of x equals c. If c is not 0, what degree does that have? What's the degree of the constant function? What's the degree of the constant function? I said it on the last slide, and we've just said it again. What's the degree of the constant function? What's your exponent in that? Do you see an exponent? No. So its degree would be 0. Okay? A linear function, what would be its degree? 1. If you don't see an exponent, but you see the variable, you understand it to be a 1. Okay? Now, in this section, we'll study only second-degree polynomial functions, which are also called quadratic functions. This section only. Next section, we'll go to larger degrees. This section, we're going to be stuck on degree 2, but there's plenty of fun things to do with that. For instance, each of these functions is a quadratic. Are you sure? Is that a quadratic function?
Yes.
Yes, the maximum exponent is 2. This has an exponent of 1, that's okay. The maximum exponent is 2. How about G?
No.
Why not? Okay. What would happen if you expanded this? X plus 1 squared. What would that do? Should be able to do that almost in your head. If not, you can fall it. Pretty exciting stuff, huh? X squared plus 2x plus 1. Maximum exponent of 2. Alright? So that is also a quadratic. What if your coefficient was a fraction? Is that a quadratic function? Yes, it doesn't matter what the coefficient is. All that matters is what the maximum exponent is. How about if the coefficient was negative? Doesn't matter. It's what the coefficient of the exponent is. Okay? How about if you had factored it? Yes, why? When you pull it, you get the first term is x squared, that's maximum exponent. The other terms are less. Minus 2x plus x would be minus x minus 2. Maximum exponent would be x squared. Note that the squaring function is a simple quadratic function. It has degree 2. All quadratic functions are of degree 2. Okay. So here again, definition of a quadratic function. If A, B, and C are any real numbers, as long as A is not 0, then this function is a quadratic function. F of x is equal to ax squared plus bx plus c. It's called a quadratic function. Now, in the old days, back in earlier courses, if that was set equal to 0, we said it was a standard form of a quadratic equation. Remember, that's the one we use for the quadratic formula and everything else, okay? That's the one we factored. That's the one we did everything with. This is not the standard form for a quadratic function. It is a quadratic function because the maximum exponent is 2 as long as that a is not equal to 0. That is called the quadratic function. Now, what does the graph of every quadratic function look like? It has a special shape. Every quadratic function has, yes, okay, I saw it written in the air there, okay? The finger of God, no, it's okay. This is the quadratic, it's called, they call it a U-shaped function. I really don't like that because U's go straight up. Polynomial functions always going up at a slight slant. That shape is called the parabola. And parabolas occur in many real-life situations. Any of you ever shoot a basketball? Yes, okay. Every time you shoot a basketball, it follows a parabolic curve, except with one exception. I don't do that. Dunk. I can't jump. Okay. Now, bet you can dunk, can't you? No? Okay. Okay. A dunk is not a parabola, but every one you shoot, every free throw, anything you shoot, parabolic. Okay? Say again? Yeah, I know, but you still parabola. Okay? When you hit a baseball, when you throw a baseball, when you hit a tennis ball, when you hit a golf ball, they all follow parabolic shapes. Okay? Every one of them. Okay? I wish we had time to do a little more with parabolas, but we don't. So I'll skip that part. Okay, next time we'll have a test, and next Tuesday we'll continue where we left off today. Didn't get far enough for any homework exercises. Sorry about that.
Do you have a copy of your tissue they went to school?
Chris, I don't know. I only made out enough for one each. So let me see if I got it.
I didn't turn my quiz in. I lost it.
Okay. guess those are zeros, huh? Okay. Let me see if I have any spares. It seems like I gave out every one, but let me see. Oh, whoa. Whoa. Here's one. Huh? You did or you didn't? Okay. And do y'all need graph paper? There's one to graph on it.
Oh, yeah,
Okay.
just in your quiz.
Huh? What's that?
The quiz.
Yeah, every one that's been turned in has been graded, and it's on blackboard. You can't until I get them all in. And people like this are. But did you see your score?
I did.
Did you see what you missed? Okay. Sorry. Talk to these people who are late turning them in. That's their fault. I can't give them back. Beat them up. Okay?
That guy, he problems will be on the test.
What's that?
How many problems will be on the test?
Like I said, it's about twice the quiz length. So it's about 20. It seems like it may even be 21.
So are we having a quiz on, a test on the quiz? Or what?
No, the test is on what I just said, 1.4 to 1.9. All 6 sections.
1.4 to 1.1?
Yes.
And we can bring a piece of paper.
Huh?
We can bring a piece of paper.
You can bring a formula and equation sheet, anything you want to write on it. If you prefer your own graph paper, bring it. Otherwise, I have graph paper for you. Okay? All right. You can bring calculators. Okay? Whatever you need.